Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. Let's see, I haven't tested this stuff yet on Mac, but yesterday we got a special kind of death animation. So if we take death in a chasm, we fall in this chasm and this little animation goes. So one thing I don't like about this is his mouth looks a little... Look at... Oh, wow. Now that we're on Mac, we can do stuff like this. How cool is that? Hey, Squinch, what's up? Oh, I love that we can do this. Yo, it's funny. Yeah, I guess it is early compared to what you're used to for me. But I used to stream at 7 p.m. my time. I think it's like 8 p.m. my time right now. So Squinch, as soon as you left, I was able to figure out everything. Literally, as soon as you left, I figured out the one thing that was wrong. We were trying to pull our global player in our play state, which in our game, our player isn't instantiated till the play state is actually changed to. So our player was just nil. So once we figured that out, we were able to get all this other stuff going. How cool is this, man? We can start doing some fun stuff with the zoom in like this. That's really epic. So the things that I'm not so sold on for this chasm fall is the parallax for the outwards of the chasm, right? So like if this were a tunnel, the rings would get faster as they get closer to our face. So I think I want to speed up the expansion rate before it loops itself. And I'm hoping that might kind of more sell that he's falling, because like it looks magical and you can infer that he's like falling, but I think if we speed up the expansion of the rings there, it'll probably sell the effect a bit more. And then the other thing is we want to kind of... I don't like that his mouth here has like a singular pixel that doesn't move. Right? So like this pixel right here is consistent with all of them. So it to me, it draws my attention to that one pixel, and it looks like just a Tetris piece for a mouth that's just getting like rejumbled, and it doesn't read as the character to me. It reads as like a Tetris mouth. So I think if we can kind of maybe swirl Tashio around a little bit, then it'll ease up the attraction that is kind of like looking right there. Because we tried for like maybe like 5 minutes, taking out one pixel at a time, trying to... Yeah, I think if we just kind of swirl him a bit, it'll help that focal point disappear. So that's what I'm hoping for. But oh, it looks epic. I'm excited. So it's gonna be, it's gonna be me jumbling through some sine wave functions, probably trying to figure out how to do that. I know we're doing some sine rotation for our fire spells, so we're already have been doing it, and we've done it for the bats, so maybe we can do something similar, right? we'll see. Maybe if we check our bat walk state, maybe we can find where we're doing the dx and dy, and just take a look at how we're doing this. So I know we use... See, look at this. So we have this offset, and we use a math.sine, and we give it a zigzag time or an argument to the sine. So what is zigzag time exactly? Zigzag time is just the time updated by delta time. So that's the constant value that's getting, or the not constant value, a value that's getting bigger that we pass to math.sine, so that math.sine will oscillate, and then we are scaling it by a zigzag amplitude, which I'm guessing we just define somewhere. I don't know what our zigzag amplitude is exactly. We don't even define it here. So we must define it in the entity defs, I would think. No. Maybe in the map declarations. Yes, we do define it here. Okay. Okay. It's a little weird that we do that way, but I guess it makes sense. So basically, we just want to modify both our x and our y by an oscillating function so that we can move him both left and right and up and down. So let's see if we can figure out how to do that. I'll try to do it without looking anything up, and we'll see what we can do. So I know we need to harpoon a couple different files. So we need our state for the game, and it is the falling chasm state. So this is what we need harpooned, and instead of, we're drawing here, we're passing a constant variable here to our math floor. So right here, this virtual width divided by 2 minus 8, that is the center of the screen. So instead of passing that, we need to pass this new x value that's oscillating between -1 and +1 or whatever. So let's see if we can figure out how to do that. Let's say that we have a variable, we'll just call it player x and player y. This should actually be like it's not that it's the sine value, but it's, yeah, you know what? No, we have to do it a little different. Let's for right now call it player x and player y, and we'll see if we can figure it out. So in the update, we need this quote-unquote zigzag time that we had last time. And all that is the variable that we constantly update to pass into our sine function. And then, so we're updating our zigzag time, and then we need to, you know what, I think my LSP settings might be wrong for Lua. Well, and you know what, actually, yeah, two indents look better than the 4 indent for Lua, so maybe we format our code so it's only indented by 2 spaces. Okay, so we need, I'm gonna check out our bat walk state again. Okay, and then this is my Mac, so I don't have all the same harpoon shortcuts as I used to have, so I'll get those kind of worked out again. Okay. So we don't need this vector, right? Because we're not moving him towards a player or anything, so we don't need to calculate anything like this. But we do need to just set in this offset for the waving around. So I guess what we can do is we can do something similar here where we can create a local variable. This is called offset. We're gonna math.sine our zigzag time. And then I actually have some autocomplete on LSP I could turn on for this too. Okay, and then we're going to scale it by, let's just say 0.5 or something. I don't know. Okay, so our offset value is going to be just oscillating. So let's just print up that offset and see what it is. We need to convert it to a string, and then we can print the offset at an x and y of 0 and 0. Okay, and it's only in our chasm state, so we should probably just change to our chasm fall state. Okay, nil. Okay. I'm trying to remember the shortcut to... There we go. Okay, so offset was local to this function. So we either need to set it as... And you know what? I need to speed up. My Vim scroll is really slow on this one. I've got to speed that up. Let's put the offset in a variable on the state, and then I think what I want to do is I think we want to change the state to chasm fall state right off the bat so we don't have to trigger it, so we can test this. So in our main, when we change our state, let's not go to play state, but let's go to chasm falling state. And I'm going to put on the... I want to put on... Man. Okay. I want to put on the autocomplete. So let me see here. LSP, where did we put... Oh, here. NeoVim LSP. So if we turn that on, I don't know if we have to reset. Do we have to exit Vim and come back into it? Let's see. Yes. Okay, we got our autocomplete. Cool. So I can get rid of this window. See, that's why I like Tmux. It's like I just want to do something on the side. I open a new window, just did my thing, and then here's my environment as I left it. Okay, so we're running the chasm state. Uh-oh. Let's try that again. Bad argument 1 to sign. If I would read my error messages, I would have known not to run the same thing. Okay, so self.offset, and then we're printing up the offset here. So we don't have an offset anymore, we have a self.offset. So let's try that. Son of a... Okay, I did the same thing. I didn't even read... Okay, it's the sign function it doesn't like. Okay, so zigzag time was defined after we used it, so we just need to swap those. Okay, so we have 0 for an offset because we aren't updating the offset by zigzag time. So let's update our offset in the delta time, and then we will see if the offset is oscillating. So we have this, it goes to 0.4 because we're multiplying it, we're scaling it down. So here, those are our oscillating function, but we need We need... Yeah, I would say we probably need to not scale this down. We might need to scale it up, because if we think about how many pixels we need to move by, you know, it might be 5 pixels. If a tile size is 16 pixels, maybe half of a tile of a wobble, you know? So we would want it to be not 2, but up to 16. And then I think I want to also try to full screen it. So let's go to our main real quick. And let's just full screen this bad boy. Does this work? Look at that. Okay. So I do want to do... I want to take off the Game Boy so that we get the full... Shoot, I was hoping full screen would fix that issue. Okay, maybe I'll just leave it off, because the whole reason was so that when I quit the game, it would bring me back to the editor, but it looks like it doesn't do that, so I might just go change that again. We might make it, we can make it a little bit bigger. Where do we do our... I call it lock screen, I think. We set a position here. Okay, it's a scale factor. So here is our window X and Y that we're drawing it at, and we did that very specifically so that we could see Sekijo down there. So we didn't cut him off. So we're scooting the window over so that we can still see the artwork back there. But yeah, I think I want it. I think I want the game just maybe, let's try a scale factor of 5, because I think we're doing... Oh, we are at 5. Let's try 6. So let's... Yeah. Let's try 6. And we'll see... Okay, nice. Yeah, and then let's just scoot it over to the left just a bit, and then that's better. Yeah. Okay, the muscle memory is going to take me a little bit to get for that. Okay, yeah, let's do 300. And I got new Get Fugitive Terminal shortcut. That is really cool. I'll show that at the end. Yo, it's just not changing. We have, this is in the play state. We set the position. It's not changing though. Because no, if you try to drag, oh. So we can move this now. Okay. We had it locked at one point. But there's got to be another set position somewhere that's overriding this. Yeah. Play state. Oh, we set it. Oh, we literally set it in the chasm falling state. Okay. Okay. So let's try this again. I think I want 300 here. Let's try chasm falling state. We should just set this in main. Yeah, there we go. Okay. Yeah, we can scoot it up. Not that this even matters, but since this is the new setup, I'm kind of wanting to kind of experiment just a little bit. Let's go set our window in main, because why are we doing it twice here? So in our main, let's set it here. I guess we just set it in love.load. we'll take it out of our play state. Yeah. Okay, let's see. Okay, we need it left. Actually, was that because we set it in the... No, we took it out of the chasm falling state. Okay, so... maybe this isn't working, because that didn't seem to move it. Yeah, that didn't seem to move it. Well, where would we put this then? If the main doesn't work... I don't know. Let's do... So, this is like my perfectionism coming out. Okay. This is fine. So let's get an oscillating value from 8 to -8, and then we'll start drawing our player at those oscillating values. Sweet. Okay. So, falling chasm state. Let's scale this by 8 instead of 2. And then I really do need to figure out how to speed up the cursor as I navigate, because that's going to be really slow. I love how someone like asks a question like, how do I speed it up? And people are like, don't speed it up, get better. Okay, I might just do this later. Okay. So we've got this oscillating value called offset. And then we want to basically update our player X by this offset. So we can't, and this is the thing that's tough for me to wrap my head around, we can't just add the offset, because then we'll be adding a bigger and bigger number every frame. So we have to like, how did we do it for the bats? We have an offset. We calculate a dx and dy based on the offset. Or no, we calculate offset and x and y based off the dx. Okay. We can just put a constant there and then multiply by the offset, but then we add the offset. See, that doesn't make any sense to me. Let's try that, because I think that just won't work. Because if we're adding the offset to our player X, so if we say self.player X gets current X plus its offset, then when we go to draw our player for the X instead of putting our virtual width, let's try to put in our player X, which we might need to keep that and also add our player X, self.player X. Yeah, that's a bit much. Okay, well, he is oscillating. But, okay. Let's do... You know, where... Zigzag time, the offset, we scale... Okay, so let's just scale this by a lot less. Because by the sine function is what makes this possible, because it gets smaller, so it'll bring us back once it becomes negative. Okay. So we do need to maybe half or quarter this and see that, and then we'll do the same thing with our y. We'll draw our y at our own y plus this offset that's oscillating, and then when we go to really? Man, dude, okay. There's gotta be a better way. Come on. Okay, player, self.player y. Yeah, I think I'm going to turn on code wrapping so I can see what the heck's over there. I just don't like the look of code wrapping. Okay. You know, he's starting at the origin position in the middle. So we don't necessarily want that. We want it to be like the origin point should be right. Well, see, and he's only going in one direction and then back. We want it to go all the way through. Yeah, how do we do that? Like if he's going, we don't want him to go from a starting point and back. We want him to go at a starting point halfway through and then halfway to the other side and then pass, so that we can say, hey, go in the middle, but then the middle is your middle point, and go on either side of your starting point. And then we can worry about the tangential acceleration. So, you know what? We might have to just Google how to do a circular rotation. We gotta grok it out. Okay. Okay, we don't want to rotate it. We don't want to rotate it. We want to move it in a circle. Okay, so we use cosine for one angle, sine for the other. Okay. And then we should get those. Now, how do we do we're drawing an X and at the X and Y, we modify the X by the center plus a radius times the math.cosine. Okay, radius is 100. Okay, let's try that. Okay, so we're gonna put a cosine here for the y value, and then we're gonna, oh, it's, yeah, it's not this. Yeah, we need an offset x and an offset y. Okay. Okay, and then what they did was they took a radius, let's say it's like 20 or something, and add it. Okay, and then, okay, now we're still rendering at our player X and Y, so we should, uh-oh. We screwed that up. Oh. Okay, yeah, we don't need that. I think the adding the 20 was just too much. Let's see. Okay, yo, that's looking sick. That's almost it, but the origin is still the very center, and we want him rotating around the center. So we just need to shift him by like half the radius or whatever. So maybe if we divide this by 5, then we can give us that radius, or they, I don't know, because it's like if we add a consistent, or we would do like maybe a -5. Can we do that? To kind of just scoot it up from the center. Oh my Jesus. That was way too bad. That was too fast. Okay, the other idea I've got is, well, we just shift it. Well, and how much is this radius shifted by? Yeah, let me turn on the line wrap so we can see this better. We need to go to our Vim config here. I think it's line wrap. No? Translate. Yes. Yeah, I know I've done that before. Where the heck is my... We have a line, maybe it's in the set here. Okay, is there a wrap here? Yes. Okay, let's try to wrap it. Let's wrap our text and then we'll see if that looks better. Okay. Okay, that just throws me off. Okay, it's whatever. At least I can see it on one screen now, so... where was I? Okay, so we're shifting, yeah, our player X here. is shifting by the virtual width. So we can just like, yeah, how? Because it's like we're saying, let's add the middle of our screen. But I think instead we want to if we do this, it should rotate around the top left corner. Okay. So if he's rotating around the top left corner, well, actually, that was not what I was expecting. Oh, that makes sense. Not rotating around the top left corner, but the top left origin point. So if we want to just scoot that top left point, oh, see, I don't know how I would. I mean, I guess if we have a set rotation that we like, we can just hard code in the offset. But it'd be nice to kind of know how to do that. I'm not so great with the sine functions and stuff. Let's scale it down just a bit. And then we'll say that yeah, I mean we could do the translate. How does the translate work again? You just tell it. Love.graphics translate. Now, do we have to reset the translate? Like if we translate in this state, will it carry over to any other renders? I don't know. Let's try to translate and we'll give it the center of the screen and then we'll just modify the translates. Like Squinch was proposing. Love.graphics.translate. And we'll give it an X of the half of our screen shifted by the half of our player, so it should be in the very center, and then the very center. So now this should get us to what we were just doing, but now we can kind of tweak the translate a bit. Oh, that's epic. See, okay, so now however wide we're rotating, we can just scoot. Oh, that looks so sick. That looks cool. Let's just, it resets at the end of every draw. Okay, that's nice. So yeah, and since this state is really limited, so well, let's say that we have another, if it was, gosh, what was the offset? Like 8 pixels? So we'd want to shift by, let's start by shifting by 8 pixels and we'll see, and then we'll make it pretty. That's almost it. It needs to be down more. Well, yeah, down and to the left more. So we can do not so much here, and then not so much here either. Yeah, still not in the center though. It's looking close. Oh, that's nuts, man. Set the translate to the center of the screen. That's what we're trying to shift, because it's like we don't want him to translate to the center of the screen. We want him to rotate around the center of the screen. So like, because when we give it 0, 0, he rotates up and to the top left, but not any further than that. We want the point he's circling around to be whatever we are telling it to. Unless I'm misunderstanding you. Well, that's looking close. Yeah, because we want him rotating around the center of the screen. That's pretty damn close. I think I like that. Oh my gosh, wait, why was our screen? Oh my god, our screen's all screwed up. If you move his sprite off center, then translate to the center. Sorry, I'm not following you. Because the translate, if we translate to the center, well, I don't know. I'm getting confused. Because we translate basically to the center, but shifted by 10 pixels to the left and 2 pixels up. So if you set the translate to the center of the screen, that's what we've got, but it's rotating around the wrong spot. So like this, well, so let me just, before we do this. So this would be the direct center of the screen. Would be this stuff. And then that makes his top leftmost spot be the exact center of the screen. So that's why we're translating by like a -10, -2 or something. Move his sprite so his sprite isn't in the center. His sprite is just rendering at whatever our result of our offset is. If you move his sprite, isn't in the center. Okay, so does that mean we set the player X and Y up here to be like God, I don't know. Okay, so you're like, what you're saying, we kind of scoot his sprite over, and then whatever we translate, that value would be what he's rotating around instead. It isn't quite these values though, is it? Not quite. Left. We need to go left. I guess it's tough because it's like I'd want to be able to calculate this based on the amplitude so that he rotates around it. I'm just too dumb to figure that out. Because if we ever change the amplitude, then this value gets jacked up. So I'm like, I just don't know how to calculate it. Okay. Still needs a little bit left and a little up. Yeah, I suck at this. I don't know the proper way to calculate that. But it looks pretty good rotating around the center there. Like, that looks pretty good. So let's see if we can speed up. Yeah, we've got the offset applied for the circling bit. So let's see if we can speed up the radius expansion. So that's going to be tough. It's not the tangential acceleration, it's the emission area. We want the emission area to grow over time. So we want, like right now it's constantly growing, but we want it to rapidly expand to give it that illusion that we're falling down the chasm. So if we just add a value, if we just add another delta time or something, I don't know. This emission area, where do we set the emission area? We just say, okay, we're gonna scale it by delta time and add it to the current emission area. That's the constant growth. But we want not exponential, but a ramping growth faster. So instead of multiplying it by 40, what if we put, how would we do this? Because the value needs to get bigger over time, so we need to not pass it in these constants. So if we multiply if we multiply this, let's do this. Oh God, this is so bad. I don't see it going faster. How would we scale this to ramp it up? Because we need this to speed up. So like if we had like we're going to constantly grow the speed ramp by delta time, and then when we set the emission area, we also add that emission area speed ramp, so it should go faster. And for now, I'm going to turn off the second particle system so that we only see the one we're tweaking, because we need to make sure it's speeding up as it reaches the out. Gosh, it just loses all shape. Yeah, it just loses shape there. So if we were to not do this speed ramp. Then it keeps its shape. Is that right? I mean, yeah, we can see those defined circles, right? So we just want, and it's tough because we might actually, I think we might actually want to ramp up. Well, yeah, I think we have to also ramp up the tangential acceleration. So I don't exactly know, but let's see if we can get the emission area speed ramped. We want to add this. I think that's just too slow. I think we want to scale whatever our speed ramp is. Let's just try to scale it by like 5 and see. Well, delta time would only grow by a 60th of a percent. 1 divided by 60. So we would want, if we multiply it by 60, it'll get us a 1 pixel expansion every frame. So it'd be 60 pixels every second, which is way too fast, right? I can't even see it. And then we got to reset our emission area speed ramp upon the reset, which we're kind of doing. If our emission area is greater than 0, we need to reset our emission area speed ramp back to 0. Okay, it's not the area we want to speed up, right? Well, emission area, yeah. Okay. Well, so if we put our emission area as 25, then it's a ring. So we want this ring to grow, but the thing is, with the particle system, the particles are spawning at this ring that we kind of declare it. So like, if the ring expands, then only the new particles will, I don't know. Like only the new particles will have the ring, like this ring. So if we expand this ring, we need to because it's like when we speed up the expansion of the ring, the particles that spawned with this smaller sized ring get inside the circle as it expands, if that makes sense. When I'm wanting like a clear segmentation. Honestly, something like this still kind of looks cool, but let me see if we put the other particle system in there. Let me see what that looks like. Yeah, it doesn't look as cool as both of them expanding, I think. So what if we just had a slowly expanding purple ring? Let's see. So let's put the emission area back in. we're scaling by this times 60. Let's try to do times 20 and see what that looks like. So purple, I need to get rid of the blue so we can see. See, it's like we lose all shape to the purple when we do that. See, we lose that circle. Oh, I guess because the emission... Okay, it must be resetting that fast. Okay, so we need to not scale the emission area that fast. So if... Yeah, we need to maybe... There we go. Okay, I can see the circle now. But is it getting faster? It doesn't look like it's getting bigger faster, but also the particle, there might not be enough particles to see it. We've got 4,000 particles and then 1,000 particles. Ay ay ay. Okay, that helps us see it. See, it looks like it's spawning too fast. Like, if our emission area is only resetting once it's 100, which means the ring is like as big as our viewport, we shouldn't see another ring spawning until the ring we're looking at has done expanding. Okay, I kind of want to just reset our tangential acceleration and just see with nothing. If we don't set our tangential acceleration, they just kind of stay in place as they spawn. Wow, that looks nuts. So they have like a random decay. Yeah, why are they taking so long to decay though? Oh, we're not... I don't know what's happening, actually. It's like since... Yeah, I don't know what's happening, actually. So they had no tangential acceleration. So if we give it just a bit, like let's just say that we're just going to give it 5 on the X and 0 on the Y. I don't know what... I don't know what the difference between X and Y tangential acceleration is then. Okay. You know what? We might need a different type of emitter for this. I guess there isn't really different types of emitters. We just run different things on it. So like there's a border ellipse. What other particle systems do we have access to here? Radial acceleration. Radial accelerates away from the emitter. That could work. Yeah, that could work. Radial acceleration. Let's see what radial acceleration looks like. Min-max. Oh, min-max. Okay, I was thinking X and Y, but it's probably min-max, which is like Y. Okay, so let's try radial acceleration. We'll say set radial, and we'll give it a min and a max. So let's say 10 and 100 for the particles. And our emission area, let's just set our emission area for right now. Let's set it to 20. Okay, so this is the radial. Oh yeah. Oh yeah. That's exactly what we want. Cause that looks like a chasm, yo. That's it. Cause yeah, now we get that circle, but they're also speeding up as they reach. Well, actually, they're not speeding up as they. Actually, I don't know. Let's continue to play around with that. Let's say that some particles are 0 on the radial acceleration and some are 200. I think it kind of sets them once. Like when a particle spawns, it'll have a random chance to either move fast or slow. But what we want is over time for them to speed up. So I think that some of them will move slow. Yeah, and some of them move fast. Yeah. See, we want each one of them to speed up over time. Because that'll really make it look like we're looking in a pit. Oh man, that's looking better though. That's looking really cool. So this is close. We just need to modify this a bit. So set radial acceleration away from the emitter. Set. Yeah, see, it's tough. It's tough because I don't think the particles are like this. Like particles kind of get spawned with a certain speed. We could set speed of a certain particle over time. See the min-max. We want to set the speed. I don't know how to speed it up over time. I don't know how to speed it up over time. Okay, let's see. Set radial acceleration, and we give it the acceleration. Increase acceleration, but cap it. We could use, well, see, I don't know how that works on a per particle basis. Like You're already using set radial acceleration. It accelerates them outwards, but if you want to speed them as they move further away, change their acceleration based on how far the particles have traveled. Oh, see? It says Love2d's particle system does not directly support dynamically changing acceleration for individual particles, but you can adjust the overall system's acceleration. This is what I was talking about. Like, I don't want to, if I set the acceleration, then it'll speed it up for all the particles, but I want only the ones reaching the outwards. Yeah, the code snippet doesn't show that it loops, because that would speed it up. Set an initial speed and adjust it over time, but that's for the particles. That's for the emitter. Since the emitter isn't changing, that'll just speed up the ones that are coming out of the emitter. So that's not quite what we're looking for. I don't think we have the ability to do what I'm thinking. So let's just try to let's do a lifetime of 3 to 6, emission rate back down to 1,000. Our radial accelerator will be from 40 to 220. And let's see what that looks like. Okay, they're just so hard to see. So we start them, let's start them not perfectly transparent, and let's say that since it's so fast, their lifetime might be as low as 3 seconds, so they should, yeah, there we go, be more visible. Okay, they're still really dark. So let's say maybe 200 to 255. Okay, that's too bright. But yeah, that's essentially what it's looking like. We're not perfectly center. We need to scoot down a bit. Yeah, we need to scoot down a bit and scoot right just a teeny tiny bit. So we'll do this. Yeah, that's looking more center. Ooh, still a little left. We can move left a little bit. Okay. Now we want a little more transparent here when they start. And then let's also set a radial acceleration for our other particle system. And we'll go to similar values, and then we'll make sure we're rendering it. Whoa. Not quite, not quite. Whoa, that looks nuts. Wow, that looks trippy, man. Okay, we don't set an emission area, and we need to make sure we give the right particle lifetime, and then emission rate, radial acceleration. We do set an emission area. Oh, we copied the one there. So let's take that out. Let's take both of these out and see. Okay, no, we do need the border ellipse emission area. Okay. I want these purple ones to be more transparent at the beginning. And then these ones to be a little more opaque at the beginning. Oh my gosh, what did I do here? Okay, we need them to fade. We need them to be more transparent at the beginning here. Oh, I changed the wrong values here. This is the opaqueness. So we want to say, okay, well, you're going to be at 20, you're going to be at 80, let's see. That does look better. Okay, a little more transparent on the purple to start out. Man, I'm getting like dizzy looking at that. I just don't want to see, I don't really want to see the circle that he's like rotating in. I just want that to be where the particles are coming from, because I don't want it to look like he's, I don't know, just want it to look like he's falling, and it doesn't quite look like he's falling. I don't get why they don't look transparent. They should look transparent at the beginning there. Okay, I was looking at the wrong one. So the purple are transparent. Yeah, yes, more like that. I don't want to see them when they spawn. Yeah, that's looking better. But they need to be brighter so we can actually see them. So, brighter when they... Yeah, so we might need a color picker for this, because I'm not going to guess the colors right. Okay, so we've got RGB 137, 230. 137, 230. Nice. Yes, that's looking like he's falling more. Yes, so like the illusion, they're not speeding up as they go towards the end, but they're becoming more visible as they reach the outwards. That looks sick. Yo. Yeah. Does that come through on the... It doesn't quite show that well on screen over there, huh? This is close. Like maybe if we do... It's looking cool. If we do a little bit shorter on some. Yeah, honestly, that's almost it. I just don't want some... See how they're like... Some of them are disappearing really fast. Wow, that looks sick, man. That looks so cool. Okay, so I think 2 seconds... 2 seconds period might be the sweet spot. Yeah. That might be the sweet spot. Yo, that might be it. I don't think we need both. That looks pretty close. That looks so cool. So that's the special game over if you fall into a chasm. That looks sick. Yeah, the mouth thing doesn't bug me as much anymore. If I really stare at it, it'll bug me, but generally it doesn't bug me. Wow, that looks so cool. Okay. Yeah, I mean, I think we just want the one particle system. I mean, just to play around, let's see how the blue one looks paired with it. We want transparent to not transparent, and we'll make sure we render it as well. Should be blue. I don't really see as many blue ones. Yeah, I don't know. Honestly, the purple looked good. Yeah. And then since we're doing the same thing anyway, if the colors weren't really coming through, like let's see if we give it a fairly strong blue to begin with and then end on super blue, we'll really be able to see. Because the only reason we would want to add the second one is for that other color. It does, yeah, I do like the little bit of blue. Yeah, maybe we do keep it. Let's do a test without it again. Bro be rotating hard, man. Well, actually, yeah, and that was, I asked AI, I'm like, how do I rotate something in a circle? And it told me how to literally rotate it. I'm like, yeah, technically it's not rotating, it's moving in a circle. You got me there, AI. But if I would have just copied and pasted that, he would have rotated, and he's already rotating, so like he would have rotated the rotate on top of his head. Because like the sprite is animated to rotate, but the actual game object isn't technically rotating, so we could get a little crazy there. Okay, let's see. Wow. Yeah, I like the little bit of blue. One thing we're going to have to test is if this works on the mobile deployment. Yeah. Yeah, I'm with you too, Salto. There was something that looked good about that. We can try to mix it. We can have one radial. Let's try to what it looks like if we have one radial and then one tangential. Let's see. I lost the tangential code, but we might be able to get it back here. If we let's see. Shoot, I just set up a... Let's see, chasm falling state. We have... Here's the old one. So let's take the old one and see what it looks like. Oh. God damn it. Damn it. What sucks about NeoVim is if you pull it to the wrong... I yanked it, and then as soon as I deleted something, I overwrote my... oh no. No! Oh, no! What did I do? What did I do, man? Okay. That was bad. Let's try that again. Okay, we're gonna run get fugitive. We're gonna go to our chasm state. We're gonna get the old line of code for our tangential acceleration that Salto liked. We're gonna yank it. We're not gonna delete anything, but we're gonna paste it. Shit. Paste. It doesn't like it. It doesn't like me pasting. We'll try yanking to yeah, I can't do it. Shit. I don't know what the hell it's asking for there. I don't know what I'm doing. Okay. As soon as I figure this out, I'll be unstoppable. Shit, man. Okay. Let's just see what it was, right? It was tangential acceleration 3010. That's all it was. So let's just do that. So not radial acceleration, but tangential. And this is like a min and max type of thing. So I think it might look like this, and we have a border ellipse that is going at an emission rate. Mission area. Okay, let's see that. Nope. I spelled acceleration twice. Okay, I'm not rendering. Am I not rendering it? Set tangential acceleration, set emission area. Yeah. And we're rendering it. Okay, so what's the problem? That still looks like radial. Oh, we we commented 1. We need to replace 1 with particle system 2. Now we're not seeing anything. 1040 emission area. Are we still growing the emission area? Yeah, but we have the speed ramp. Let's get rid of the speed ramp. Really? Salto, this is the story of my life, dude. I tried to do something that I thought would be super easy. What's wrong? We have a particle lifetime. Oh, we're not even setting a particle lifetime for it. Okay, we give it a particle lifetime. Damn it. Shit. All right. Emission area, emission rate, and acceleration, and a color. So let's just come back to somewhat transparent at least. Let's just see any sort of emission, and I'm not seeing any. The emission area starts at 0. The emission area scales by delta time. We're setting an emission area. Let's literally just change this to be 200, just so we can see the damn thing, and we can't even see it. So what the hell is going on? Particle lifetime is 2. We're setting the color. We're not updating it. We're not updating our particle system. We still can't see it. What the... $200 is way too big. Okay. We got it. We got it. We got it. Okay. So let's try this again. Let's pair these two together, but let's do the emission area, the growing one, like you liked, like the whoosh, the like whooshing wave of it. Emission area. Okay. Okay, so there's that. It needs to be bigger. That emission area doesn't look like it's growing, does it? Emission area. It is only growing by a 60th of a delta time, so that's probably why we needed times 40. Okay, that... Whoa, that's nuts. What the... That looks so weird. It looks so weird. It looks cool. It looks cool, but let's see, because let's do less. You know, let's only do like 200 of these ones. Looks a lot less cool, huh? I'm just a little worried about the web deployment. I don't know how many particles our web deployment build can hold or render in the WebAssembly. But maybe we do this one paired with the other one we just made and make these less purple and more blue, so we kind of have like layered colors in there. So like if we want less purple, maybe this is 40 and it ends, maybe has a higher blue value. Yeah, let's see what this paired with the purple one looks like. because this is the whooshing tangential one, but then we have the radial one as well. So maybe pairing them up will look kind of cool. Let's see. We need to do the same thing where we need to make them start transparent and fade into color so they kind of become more visible. So this second, or this 100 here should be 0. So they start transparent. Yeah, you know, I like the two different movements of it. I think it's too blue, but the circular whooshing paired with, well, I don't know, because they're two different movements, so it kind of, it looks cool though. It looks cool. I don't know I don't think it sells the falling as much as just the purple. But let's try to tweak it just a bit more and see. Yeah, I'm not sure. I don't think it doesn't read as much as falling. When they were the two layered tangential ones, it did look really sick. But I think the effect is sold more with just the radial. Well, I don't know. It does look cool. Well, I'm going to look at this for a little while, and then we'll try just the radial and look at it again. So, because it's like at some point, it kind of just looks like particles, and it doesn't really look like... It looks cool, but it doesn't look like what we're actually doing, which is falling down a chasm. So let's see what just the purple looks like again. Yeah, I think we stick with just the purple. But I did like, there was one iteration in there with the tangential ones that looked really sick. But I think this is the one. Yeah, I'm wanting... Maybe we can try the start point, not 0, but maybe the start point is like 20 or something for the opacity on this first one. Yeah, let's try 20 or something. Yeah, as we creep that up, you can see more of the circle. Yeah, I think that's the sweet spot right there. That looks so sick. Is the speed good? Yeah, I mean, I think any faster than that, it would kind of make me dizzy, more so than it is. But I think that's money right there. Now, one thing I am worried about is, like, I guess because we're in the chasm state, we're not rendering the Game Boy. Oh, see how jacked up the Game Boy part looks? If we shift our, what's it called? Scale factor. Oops. Yeah, see, why did our Game Boy got all screwed up? But also, this is how we can see, you know, we can see when these particles are despawning, and it's like just outside. A lot of them are just outside the radius there. So some of them, we could probably lessen the upper end of the lifetime of the particle, and then we can kind of optimize that a little bit. Not that it's a big deal. Oh, there's only 2 there. Maybe that's, I wonder what happens when you give it just one argument there. Okay, well, okay, 2 it is. Yep, I think we get rid of this second particle system. I don't know. This is like a bad habit where I don't want to get rid of the stuff I did, so I'll just like comment it out. But then that just makes it nasty in the future. So maybe we should just kill it, but for right now, I'll just leave it. Okay. So we don't have the particle system anymore, and we're not rendering it either. Well, we're not updating it, and we're not rendering it. But we still have the emission area for the looping in case we wanted to go back to tangential. I don't know why the Game Boy is all screwed up on this page. Let's see if it's screwed up on the other one. Like if we, in our main, if we go not into chasm, but back to our play state, does it still screw up? No, it's fine. Okay. Why does the Game Boy UI get all screwed up there? I don't know. We can check in our play state how we're rendering it, and maybe there's a reason for that, or we do a Game Boy HUD or something. What do we call it? Game Boy overlay is what it's called. We draw it at 0. Is it because of the translate, maybe? It might be because of the translate. That's the only thing I could think of. If we don't translate... Let's see. Okay, yeah, it is the translate. So how do we just translate our player? Yeah, maybe, I don't know. I'm gonna have to, I don't know how to do that properly with the translate. Or there's a pop. There's a pop, a push and a pop we can do. Right, so like, is it push and then translate and then pop and that'll untranslate it? Or our Game Boy UI? Yo, Puny, what is up? How's it going, man? Oh, it worked. What? That freaking worked. The push and pop worked. You can set translate to empty. Oh, okay. So after, yeah, let's try that. That's probably... So you would just translate nothing like that. Number expected, so 0. Yo, Puny, hey, I don't feel like programming most days. Because I'm tired from work. I literally just hit stream and then I'm like, I'm streaming now, so I kind of just got to do it. All right. I don't know how to get that working, Squinch. No, I think you're right. I mean, I think I remember something like that where you could translate, reset the translate. Oh, shoot. We died. Oh. We didn't die in the chasm, so we didn't get to see it. But yeah, Puny, it's okay, man. It's tough. It's tough. It's really tough to find the motivation. That's why I started recording myself in the first place, because I would get distracted and then not work on the game. So I started literally recording myself, pretending like I was talking to people, so that I would stay focused. Don't you have to set translate to the origin when you want to clear? I don't know, man. I don't know. I've been trying to figure it out. This is good though. This works. This is great. So we'll need to add a game over on this screen. You know, we'll have like a special game over up at the top or something, and then it'll be continue or exit. And then continue will load your last save, and exit will load the title screen again. So we'll change that. And I don't think, yeah, the purple isn't coming across too well on the stream. Well, it is. I guess it's a little hard to see the colors, but it looks good on the game. So I'm curious about testing this in the mobile deployment soon. And then, oh, really? Well, maybe, yeah. That's tough. I mean, you can, my whole deal was like, I'm just going to do, 5 minutes a day. And then it ends up being more than 5 minutes, but any amount, just say like, I'm just going to get 2 minutes dev work on it, and then just do 2 minutes. And as you're doing 2 minutes, you're like, might as well do 15 minutes or might as well do 30. So that's kind of how I treat it. Okay, this is looking good. I like this. I think we'll call it a night because it's been 2 hours already and I have not eaten dinner. We've got this get fugitive we can check now, which kind of lets us preview our changes. So we have a chasm falling state in our main. We change a scale factor. We reset our screen lock position. What the hell? And then we changed all of our particles. The biggest thing being a radial emission instead of a tangential. And then, how do we do this? Okay, and then we change our set position in our play state as well. So that looks right. So that all looks right. So we can git commit and add with a message saying that we want that we added radial chasm particles. That's basically all we did. But today was also testing. Oh no. Why do I need my... Shoot. Did that get logged at least? No. Oh, come on. All right. I'll get push it off stream, but thanks for watching, y'all. Thanks for hanging. Hope the new setup is kind of cool. I'm gonna keep tweaking it a bit. The big selling point, I think, is the Sonic Pi here in the editor in NeoVim, so we can modify our track as the stream is going. You know, we can take out the melody, or we can tweak. What was I even doing here? Oh no. Oh no, I just screwed it up. Okay, well. Yeah, I love the Sonic Pi in the NeoVim there, so we can play with it and update it as the stream goes. So I think that's a super cool addition. I'm hoping, I want to be able to kind of like whip up beats for the stream in the first 5 minutes, and then code, and then commit. Like I want to basically just be able to whip up beats and songs here in Sonic Pi on the daily. So that's a skill I want to be practicing. And then I've already got a repo for it where I'll be committing all the files, so that I can, you know, have a list of all the stuff that we created. I think it'll be cool. Yeah, we're gonna raid out here. Brightside Movement. He's always working on his Unity game here. What did we screw up here? Oh shoot! I can't raid because of my setup. Shoot. There's gotta be. Hold on. Is there a button I can raid? I can't type because my Switch. I'm on Mac and PC, so I have to kind of swap over. Type because my Switch. And then I can raid, I guess. I'm on Mac and. Oh, what a mess! I'll have to figure out how to raid with the new setup, but we'll raid Brightside and call it a night. Thanks for hanging, y'all. I'll be back tomorrow, and we'll probably get the game over, continue state and exit to title screen, and we might make like a placeholder title screen. And then we'll have to figure out how to save our current game state so that we can load, you know, how many coins you had when you last died, or which bed you last rested in and saved your stuff in. So that'll probably be next. Anyways, have a good night, y'all. Get some dinner. Stay hydrated. Thanks for watching.